Let us revise whatever was taught in the class on probability. It is a measure of the likelihood of an event will occur. For example, if you roll a die with six faces, one can come, two can come, four can come, five can come, six can come. So the likelihood that any one face, for example, what is the probability that it will throw up two? The likelihood of the probabilities out of or one by sorry, it is one out of probability is the measure of the likelihood of an event will occur. For example, if you flip a coin, only two things can happen. Either head will come or the tail will come. So there are two possibilities. So probability of getting either this or that, either head or tail, is one out of the two possible possibilities. So in that case, we'll say heads probability is 1 by 2, tails probability is 1 by 2. And you observe that 1 by 2 plus 1 by 2 is equal to 1. Even if there are 10 different possibilities, 10 different probabilities. For example, if you are rolling a die which has got six faces, each face has got a chance of 1 out of 6. And there are six faces, so 1 by 6 plus 1 by 6, 6 times, it comes 1. It is quantified as a number between 0 and 1. And it has got applications in business, insurance, in finance, in stock market, in data science. That's why we are studying it here. Now, the definition in mathematical terms, P of x, probability of x happening, is the number of possibilities that satisfy the condition and total number of. So there are 10 different things are happening. Possibilities are there. So A, B, C, D, etc. 10. So in that case, it is probability of A, probability of B, probability of C, probability of D, probability of up to or 10 numbers. The total of that will be equal to 1 because probability, each of them will be within 0 and 1. And it's sum of all of the probabilities, the total number has to be 1 or 100%. Now, probability of third says probability of A and probability of not A. So, for example, heads coming is 1 by 2. Heads not coming, that is tails coming, that is also 1 by 2. So, that is called the complement, something not A. So, that put together is also equal to 1. Three different fields is classical probability, empirical probability, and subjective probability. Now, classical probability, it is like of a coin. We're calculating in a theoretical manner. Theoretical probability measures the likelihood of event occurring based on the assumption that all outcomes of the sample space are equally likely. So if you have a fair die, then we know theoretically also as empirically also, a fair die that means it's not loaded on one side. Good chance of same chance of head coming or the tail coming. The number of favorable outcomes. Suppose I say two friends are flipping a coin. I say head will come and he says tail will come. I will get a 1 by 2 chance and he will also have a 1 by 2 probability. Because the total number of possible outcomes are 2. And only one can come. If I consider that getting a head is my success, I'll have 1 by 2. He says if it is getting a head for him is a success, and if head comes, he gets success. Obviously, both of us cannot be successful if I decide that only head will come. Decides that the tail will come. Rolling a fair six-sided die, each face has got a probability of 1 by 6, coin 1 by 2, drawing a card from a standard deck of 52 cards. So if I want to know the probability of drawing an ace, there are four aces, four different colors in the pack of cards. So 4 by 52 is equal to 1 by 13. Empirical is known as the experimental probability. The probability of an event occurring based on observed data or experiments. So rolling a die, if I roll it 100 times and the number 4 appears 20 times, I'll say based on the experiment that I conducted, 4 came 20 times out of 100. So theoretically, 4 should have come 1 by 6 times. When I conduct the experiment, 4 came only 20 times. Survey results. A survey of people, 500 people, finds that 150 people prefer a certain brand of soda. And the empirical probability is 150 people prefer that out of 500. So the probability of people preferring that brand of soda is 150 divided by 500, which is equal to almost 0. It is actually equal to 0.3, not almost. Subjective is based on our experience. Meteorology can forecast that 70% chance rain tomorrow based on various factors like his own experience with the place and the weather, years of data which is available. So there is no model, it is based on the thinking. So that's why it was subjective. Stock market, some may say that there is a chance that some particular stock or share of say Infosys, yes, Reliance may go up. That is that person's subjective judgment. Similarly, sports, that India England match, the 90% chance of India winning is not based on any mathematical model, it is based on the subjective judgment. Now, probability space stands for all possible outcomes. For example, in coin toss, the sample space is heads, comma tails. Only one of these two can happen in the case of coin toss. The case of die, it can be 1, comma 2, comma 3, comma 4, comma 5, comma 6 in the curly bracket because only one of these spaces can come whenever you throw the die. Now, random experiment is a process that leads to several possible outcomes. Like flipping a coin is a random experiment. Outcomes can be either head or tail. Drawing a card, it can be any of the one by of the 52 cards. So they are called random experiment because each card has got an equal chance of coming out. And die, each of those 1 to 6 have an equal chance of coming out. So that's types of random variables, two types, discrete and continuous. Now, coin tosses, they're discrete because 1, 2, 3, 4, 5, etc. Numbers only can. Continuous means between 1 and 2, there can be 1.1, 1.2, 1.3. Between 1.2, 1.3, there can be 1.21, 1.22. Between 1.21 and 1.22, it can be 1.21, etc. It means infinite number of, even discrete also can be infinite. But here it is still further because, for example, if you are measuring the height of people, it can be 165 centimeters, 165, 1.1 centimeters. It can be 165.11 centimeters. Any variable can be. But if you're taking a number of people, then you can only take 5 people out of the 100, 7 people out of 100, or 25 people out of 100. You can't take 25.35. That is good. Selecting certain number of people sample in a population and take it as a sample, that is a discrete one. Whereas measuring their heights or weights, that is a continuous random variable. The sample space of a random experiment is a set of all possible. For example, when you're rolling two dice, you can have 1 and 1 coming, have 1 and 2 coming. That is 1 on one die, that second 2 on the die. So 1 on the first die, 3 on the second die. 1 on the first die, 4 on the second die. And 2, 1, 2, 2, 2, 3, up to 6, 6. So 6 multiplied by 6, there can be 36 combinations of the dice. So that becomes a sample. Events can be mutually exclusive. That means they cannot occur simultaneously. Head comes, tail cannot come. If tail comes, head cannot come. In die, if one comes, other things can't come. If five comes, one, two, three, four cannot come. Independent events are those where the occurrence of one does not affect the occurrence of the. Now, we have got a card of 52 cards. Pick up one card, look at it, and keep it out. Take another card. Now, suppose you have taken a red card. There are four colors, sorry, two colors, red and black, 26 red, 26 black. Suppose you take one card and then you look at it and see if it is a red card. Now, out of the 26, you have taken one out already. Now, the probability of getting another red card is not 1 by 26, it is 1 by 25 because they are dependent events. You are taken the card out and therefore it has got an effect on the next card. So they are dependent events. If you replace the card after taking out, then they're independent events. You have taken the card, saw it red, put it back, then again take one more card. So it remains at 1 by. Die is thrown at random, probability of getting 5. Only one 5 can be there, so 1 by 6. Greater than 4. Greater than 4 can be 5 can be there, 6 can be there. So there are two probability, two chances. 2 out of 6, that's already 1 by 3. Getting an odd number. The odd numbers are 1, 3, and 5. 3. Any of the 3 coming is successful. So 3 out of 6, that's 1 by. 2 dice are thrown one time. Sum of the number should be 5. The number 5 can be the combination of 1 and 4 and 4 and 1. 2 and 3 and 3 by 2. 3 and 2. So there are 4 chances. Out of how many chances? 36 chances. As we saw that 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, etc. Going up to right now. So 4 of them satisfy this condition that the sum of numbers is 5. So 5, so 4 out of 36, that is 1 by 9. Next is sum of the numbers is 10. 10 can come only when the combinations are 4, 6, or 6, 4, or 5, 5. So 3. So it is 3 by 36, but 1 by 12. Now come to the addition rule of probability. Addition rule is used for finding the probability of the union of two events. Multiplication is the intersection. Bayes theorem, we'll explain in another chapter, another video. Now, addition rule is used when calculating the probability either of the two happening. For example, in a rolling of a dice, the probability of getting either 3 or 5. Now, 3 probability is 1 by 6. 5 probability is also 1 by 6. Either 3 or 5 is 1 by 6 plus 1 by 6 equal to 2 by 6. And that is because if one comes, sorry, 3 comes, 5 cannot come. If 5 comes, 3 cannot come. So they are mutually exclusive. And therefore you can add without any subtraction. Here to subtract, we see. So because the events are mutually exclusive, where in that case, they are just added. The intersection is now the probability of A is the entire circle here. Probability of B is entire circle here. This one, which is common to both A and B, that is called intersection and is shown like this in mathematics. These are called Venn diagrams. In that case, the union is not just P of A and P of B together, because when you are taking P of A, the whole circle is counted. When you're taking P of B, then the whole circle B is counted. That means this portion is being counted twice. What you have to do is first you have to count only this A, then you have to count only this part. And because we are counting this portion twice, that has to be subtracted. In case of where the intersection is not equal to 0, A union B is equal to P of A plus P of B minus P of A intersection. Now, condition probability means probability of A happening, provided B has already happened. Read as P, probability of A given B is equal to probability of A intersection B, that is how much is the amount here, divided by probability of B, that is equal to probability of A given B. So in the case of heads and tails, head has got 0.5 probability, tail has got 0.5. And head happening, tail cannot happen, tail happening, so for intersection equal to 0. Independent means the occurrence of one event does not affect the occurrence of the another event. Mutually exclusive, intersection is 0, like heads and tails is 0. Independent, one does not affect the other. Then P intersection, A intersection B is equal to probability of A into probability of. Now, multiplication rule is used when calculating the probability of both events happening. For example, probability of getting a head on a coin toss, 5 on a dice roll. Now, here if you see, A intersection B, in this case, A intersection B is equal to 0. That means rolling of a head, the coin, flipping of a coin has no bearing on the rolling of a die. Therefore, we can multiply without any. So 1 by 2 for the either head or head, and 1 by 6. So getting a head is 1 by 2, getting a 5 is 1 by 6. Therefore, both should come. It is multiplication. Fair die is rolled. What is the probability of rolling an even number? Even number can be only these three, 2, 4, and 6, three of them. Each outcome is equally likely. The probabilities 3 by 6 are equal to 5. Now, here in this case, a card is drawn at random from a standard deck of 52. Getting a heart. Now, we got 4 suits, that is hearts, diamonds, clubs, and spades. And each of them about 13. So 13 hearts, 13 diamonds, 13 clubs, and 13 spades. Now, we want to get a heart. 13 hearts out of 52. So a heart is equal to 13 by 52, 1 by. Probability of either event occurring, then we have to use the addition rule. The card is drawn in a standard deck. Probability of either a king or a heart. A king or a heart. So there are 4 kings in a deck and 13 hearts are there. Now one card, that is king of hearts, as you can see here, king of hearts, has got in red also. So it is 4 by 52. There are 4 kings in a deck. So 4 by 52. And there are 13 hearts, 13 by 52. But one of them can be counted here also. Counted here also. So because we are talking about 13 out of 52, 13 hearts. So therefore you have to subtract 1 because there is 1 heart and king together. 1 king of heart. King of heart is there. That has already counted in the either in the king's hearts. Therefore, it is 4 plus 13, 17 minus 1 is 16. 16 by 52 is equal to 4 by. The probability of rolling a 3 or an odd number. Now remember, the 3 is also an odd number. Then you don't have to subtract because 1, 3, or 5, any one of them can be drawn. But 3 is already counted and you don't have to subtract anything. So it is, since 3 is already included in odd numbers, 1, 3, 5. So 3 of them can be there. And therefore 3 by 6, not 1 by 2. A fair coin is flipped twice. Probability of both flip result in heads. The one flip 1 by 2, another flip 1 by 2. Both has to be 1 by 2 into 1 by 2. Because they're independent. 1 by 4. 2 aces drawn consecutively without replacement. You draw one ace, it is outside still, and try to draw another one. So that is, first you get 4 by 52. Now having drawn one, now there are 51 cards only left. There are only 3 aces left. So the next probability is 3 by 51. So two cards drawn without replacement, probability of both are aces is given by the multiplication because they are dependent. Therefore, drawing the ace first has got as an effect on the second one because the cards are reduced and aces are reduced. And calculated is 0.0045. A card is drawn for a deck. Given the card drawn is red, what is the probability that it is dead? The number of red cards is 26. The number of diamonds is 13. Now, probability of the card being drawn is red is 13 by 26. Red cards is 26 and it is a diamond. There are 13 diamonds. So probability of it being a diamond red card is 13 out of 26 is equal to 1 by. A bag contains 5 red, 4 blue and 3 green balls. 2 balls are drawn randomly. What is the probability that both are red? The number of ways to choose 2 red balls from 5. We're talking about choosing 2 balls from bag containing 5 red, 4 blue and 3. Now, we want them to be red. So 2 red balls to be taken out of the 5 is given by the formula 5C2, 5 combination 2. And the formula for 5 combination 2, 5C2 are written like this inside the bracket is 5 factorial divided by 2 factorial into 5 minus 2. In general, NCK is n factorial divided by k factorial into n minus k factorial. So in this case, n is 5. So that comes to 5 into 4 into 3 into 2 into 1. 2 factorial is 1 into 2. And 5 minus 2 is 3. So that is 1 into 2 into 3. You cancel 1, 2, 3 with 1, 2, 3 on top. So it will get 10. Total ways of choosing 2 balls from 12. Balls out of 12, that is 2 balls are drawn. And there are total 5 plus 9 plus total plus 3, total 12 balls. So total ways of choosing 2 balls is 12C2, that is 12 factorial divided by 2 factorial into 12 minus 2 factorial. So when expanded is 12 into 11 into 10 into etc. That will cancel with 12 minus 2 is 1 into 3 into up to 10. So up to 10 it gets cancelled. So what we left is only 12 into 11. And down below only 2 factorial is equal to 1 into 2 is equal to 2. So ways to choose red is 10. Ways to choose any balls is 66. This 10 by 66 is equal to 0.1515. Bag contains 4 blue and 2 white. 3 balls are drawn at random. Probability of that 2 are blue and 1 is white. Same. Total combinations are 20. 6. Because 5, 6. There are 6 balls. And we are taking 2 at it. Combination 2 is the total number of combinations possible. 20. And, taking 2 blue balls is 4 out of 2. That is 4C2. Combination of 1 white ball is 2 out of 1. 2C1 is equal to 2. Now multiply these two combinations together. Several have done. 6 into 2. We want 2 balls blue and 1 ball white. That is the problem. Calculate probability of 2 balls. Three balls are drawn at random. Probability that 2 are blue and 1 is white. 20. Now we want both of them to come together. 6, 2, 2 blue and 1 white is 12 out of 20 is equal to 0.6. Which one two combination to get the favorable outcomes? Favorable outcomes are into 2 out of 20. 60 men and 40 women in a factory, and 3 employees are selected at random. Probability that the selected employees are all men, but the probability of selected employees are at the most 2 men. So for that, selecting man first is 60 by 100. Because 60 men are there. Now one man already selected. Now we have only 59 men there and 99 total. So next man being selected is 59 by 99. Third one is 58 by 98. So to get all of them to be men, you have to use a multiplication rule. So 60 by 100 into 59 by 99, 58 by 98, 0.2116. The answer to the now at the most 2 men. That means all 3 are not. So that is a complement rule. All 3 men is equal to 0.2116. All 3 men are not there. That means at the most 2 men are there. That will be got by subtracting 0.2116. 1. Total probability is 1. So 1 minus 0.2116 is the answer. 0.7884 or 8.8. So mutually exclusive events, P of A or B. When you say or, then it is addition. P of A plus P of B. They are mutually exclusive. When there is an intersection, then you have to subtract the intersection part. Roll a 6-phase die. Probability of rolling a 2 or a 5 is 1 by 6 and 1 by 6. Therefore, 2 or 5, 1 by 6 plus 1 by 6 equal to 2 by 6 is equal. When they're not mutually exclusive, then you have to subtract the intersection part. Draw a card from a standard deck of 52 cards. Probability of drawing a red card or a face card. Red card is 26 by 52, 1 by 2. Face card, there are 12 face cards, 12 by 52, 3 by 2. Red face card, both should be set. Then you have to multiply 1 by 2 into 3 by 30, 3 by 20. But if you are talking about red card or face card, then 1 by 2 plus 3 by 13, and you have to subtract the intersection part of it, which is 3 by 26. And that multiplication rule, P of A and B equal to P of A into P of B, where there are independent events. The occurrence of one does not affect the occurrence of the other. Flipping a coin and rolling a die are independent events. Therefore, you can use this formula. Flip a coin, 6-phase die. You want to get heads, you want 4. 1 by 2, 1 by 6, or 1 by. Dependent events, the occurrence affects the occurrence of the other. Draw a card without replacement, probability of getting ace followed by a king. Now, first card is ace, 4 by 52. Second is a king. We're not talking about ace here. And kings, all 4 kings are inside. Number of cards has reduced now. 52. It is now 51. 4 are 59. So, and means you have to multiply. 1 by 31, 1 by 13, 4 by equals 4 by 6, 3. Bayes theorem, we'll see it another video. Please practice this problems so that you are exam ready. Thank you so much.